It can be challenging to build an automated machine that runs a variety of different parts. And I would call that variation of the SKUs. There's also variation within a specific part, like injection molded part tolerance, warping. I'm just going to target talking about different SKUs running through the same machine. The price is driven up because we need to make sure all of the different parts can be located, and so that could require a lot of different nests. It also requires different sensors to find the part, and then we have to test each part individually. And we would generally have to change the different types of methods, the axes of motion, because pneumatics doesn't always work. We can't always pick up from the same spot, place to the same spot, where pneumatics are best when you're using two positions. So it changes a lot of the axes of motion into servos or motion control, which costs more money for the hardware, take longer to program, and then take longer to validate in the field with all the settings. And so when you need a machine to run a variety of SKUs, the cost goes up dramatically. So what Engineered Vision does to counter some of those things is we standardize on products that deal with flexibility. So flex feeding, for instance, we've gotten very good at robot feeding cells. We use the same hardware, we use machine vision, we try to design the end of arm tool to be able to pick up a variety of parts, sometimes 20 to 30 different part variants, different SKUs. And so flex feeding is our number one saver for dealing with different types of components in order to justify automation. So you need to get enough volume to need automation. And if to get to that volume, you need to add a lot of different part SKUs, flex feeding is our starting point. Now, depending on what you need to do to the part, would be application specific. Another big tool that we use to unlock automation return on investment is to ensure that you only automate the parts that need to be automated. And so if we can handle 20% of the SKUs and that actually makes up 80% of the volume, we would identify those at the start of the project and just try to automate those parts. That can quickly reduce the scope of the project, and the other parts can be made manually or on an existing process, which helps justify automation quickly and simplifies the project scope. We can also do a phased approach where our team automates that first 20%, and after we accomplish that goal, we can decide to build a second machine or expand the first machine to go into a phase 2 to handle more part SKUs, which we've done plenty of times.